Hi, I'm Sean Gannon, and this is MinuteMath. Today we're learning about the Mega Millions. What are the odds of winning the Mega Millions? Now, if you're like me and you're paying attention, the drawing's tonight, okay? And probably by the time you watch this video, it has already happened. Either we're going to have a winner or multiple winners, or it's going to go on to the next round. Well, right now, the jackpot prize is at $1.6 billion. Now, you know you're not going to get all that, right? There's taxes, you only get the lump sum payment, etc. But still a good amount of money. So what are your odds of actually winning that? Okay, so we're going to show you the math behind winning the Mega Millions. The way the Mega Millions is set up as of this video is you have two pools of numbers. The first pool of numbers is numbered 1 through 70, and you have to pick 5 unique numbers. The second pool of numbers is labeled 1 through 25, and you only pick one of those. If you get all of them right, you will win the Mega Millions. Now, there can be multiple winners, or just one. It can all be yours. All right, so now choose wisely your numbers. So let's go through the math behind this. We first want to find the odds of getting the first 5 numbers correct. To do that, we have 70 balls that we can pick from the first, right? Or 70 numbers from the first pool of numbers. So what we want to do is take that 70 factorial, and we're going to divide that by the number of numbers that we can pick, 5 factorial, multiplied by the total number of options, 70, minus 5, the number of options we're going to pick, and that's going to be factorial as well. Alright, well, this is kind of hard, and we can simplify this a little bit. We have, 70 factorial over 5 factorial over, 70 minus 5 is 65. So we're simplifying this a little bit. So we have 65 factorial here. Now, if you try to type 70 factorial in your calculator, that's going to be hard. So let's go understand what 70 factorial means. 70 factorial, or factorial in general, is starting at 70 and multiply by each integer below it until we get to 1. So 70 factorial is 70 times 69 times 68 times 67 times 66 times 65, and that goes down all the way to multiply by 3, 2, then 1. Okay, all the way down. So let's go do this for each one here, right? I'm not going to write all of that out, but we can see we're multiplying by each one. 70 times 69 times 68 times 67, all the way till we get to 1. All right, it's a very large number. So apply the same principle to 5. 5 times 4 times 3 times 2 times 1, that's 5 factorial. Multiplied by, now multiplication, we just put all next to each other, 65 factorial. 65 times 64 times 63 times all the way down, multiplied by 3 times 2 times 1. All right? Now hopefully we can do some math here and recognize, instead of multiplying the numerator out and then multiply the denominator, we can cancel some things out. We can see there's a 65 and then 64 will cancel all the way to the 3, 2, and 1. So this becomes a much more manageable problem. All right, we have, let's bring it down over here. Okay, we have, that's just 70 times 69 times 68 times 67 times 66 over 5 times 4 times 3 times 2 times 1. Multiply out the numerator. We can do that in our calculator. We get 1, 4, 5, 2, 3, 6, 1, 6, 8, 0. And divided by 5 times 4 times 3 times 2 times 1, which is 120. This comes out to be, we take this large number, 1, 4, 5, 2, 3, 6, 1, 6, 8, 0, divided by 120, and we get 12,103,014. All right? But that isn't really our, what does that mean, right? That's a 12,103,014 chance of picking the first 5 numbers correctly, okay? So that's our 1 in that chance of getting the first 5 numbers. So we're going to keep this number in our back pocket there, okay? Now we're going to look at the second pool. Okay, we have to find the odds of getting the second poll correct. Well, this one's actually pretty easy, right? There's 25 different numbers you can pick from, and you pick one, so the chance of getting that one right is just 1 in 25. Okay, so we have a 1 in 25 chance there. Okay, so what we want to do, we take the odds of the first ball, is 1 in 12,103,014, and we multiply that by the chance of the second ball, which is 1 over 25. The numerator, we know, stays the same, right? It's just 1, right? 1 times 1 is 1, but the denominator, when we multiply that out here, what's 12,103,014 times 25? Well, that's 302,575,350. And that's our chance. That's a 1 in that chance, 302,575,350 of winning, getting the right numbers for the Mega Millions. Pretty slim odds there. All right, so what is that actually as a decimal? Well, approximately, so that approximately as a decimal is 0. How many zeros? I think it's 8 zeros. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 2, 3, 4, 5, 6, 7, 8 zeros. 3, 3, 0, 4, 9, 6, 1, 8, 8, 8. That's this 1 out of 302,575,350 as a decimal. So we write that as a percent. As a percent, that's 6 zeros. 1, 2, 3, 4, 5, 6. 3, 3, 0, 4, 9, 6, 1, 8, 8, 8% chance in winning. Again, pretty slim odds. So hopefully you got the right numbers. We'll see if someone wins tonight, or if it goes down to a